What if we could create a perfect digital copy of the universe, one that behaves exactly like the real thing, obeying the same laws of motion, thermodynamics, and quantum mechanics? What if we could test a new fusion reactor, predict earthquakes, or design next-generation materials, not in a lab, but inside a virtual world powered by artificial intelligence? Welcome to AI-driven physics simulations and digital twins, one of the most revolutionary frontiers in science and technology. You're watching the Learning Studio, and in today's episode from our physics playlist, we'll explore how AI is transforming the way physicists simulate reality itself. You can watch the entire playlist by clicking the link in the description below. This episode is part of our section Physics Meets AI, the computational frontier, where the boundaries between science, simulation, and intelligence begin to blur. The concept, from models to mirrors of reality. For centuries, physicists have built mathematical models to describe the world, Newton's laws, Maxwell's equations, Einstein's relativity. But as systems became more complex, like turbulent fluids, fusion plasmas, or global climate, these equations grew too vast for even supercomputers to solve efficiently. Enter AI-driven simulations and digital twins. A digital twin is a precise virtual replica of a physical system, from a single atom to an entire power plant or even the planet itself. It doesn't just visualize, it learns. It takes in real-world data from sensors, satellites, or experiments and continuously updates itself, learning to predict future behavior with astonishing accuracy. With the power of machine learning and neural networks, these twins can now model complex physical phenomena faster and often more accurately than traditional simulations. How AI is changing physics simulations. AI doesn't replace the laws of physics, it augments them. Traditional physics simulations rely on first-principle equations, systems of partial differential equations that describe how matter and energy evolve. But solving these equations for real-world systems, especially in 3D and over long timescales, can take months or years. AI changes the game. By training on simulation data or direct measurements, neural networks learn the hidden patterns that govern physical systems. They can then make instantaneous predictions about system evolution, effectively becoming a learned version of the physical model. For example, in fusion research, AI-driven models predict plasma instabilities inside reactors, helping scientists maintain stability in devices like ITER or Spark. In climate science, deep learning models integrate satellite data with atmospheric simulations to forecast global changes with higher spatial precision. In materials science, AI simulates atomic structures to discover new alloys, superconductors, or nanomaterials before they're ever synthesized in a lab. These aren't static models, they evolve, adapt, and self-correct as new data arrives. Digital twins, the virtual labs of the future. Imagine a fusion reactor where every magnetic coil, plasma current, and heat flow is mirrored inside a digital twin. This twin runs in real time, predicting performance and warning engineers before problems arise. Now imagine a digital Earth, a complete simulation of our planet's climate, oceans, and atmosphere, constantly updated by satellites and sensors. Physicists and environmental scientists could test how different policies or natural events might affect the future, before they happen. This isn't a distant dream, it's happening now. Projects like the EU's Destination Earth, NASA's digital twins of spacecraft, and AI-assisted climate models are building these real-time, learning-based mirrors of the physical world. And in the next decade, as AI grows more powerful, digital twins will become essential tools for everything from quantum materials design to interplanetary exploration. AI plus physics equals symbiotic intelligence. The beauty of this revolution lies in collaboration, not competition. Physics provides the laws that define what's possible. AI provides the adaptability to handle complexity beyond human reach. Together, they create a symbiotic intelligence, one that learns from both theory and experience. This partnership allows scientists to simulate quantum systems at atomic resolution, predict extreme weather event days earlier than before, optimize particle accelerator beams in real time, create new energy-efficient materials for the post-carbon world. It's not just simulation anymore, it's co-creation between physics and artificial intelligence. The next decade, building a digital universe. In the coming years, expect AI-driven physics simulations to expand into nearly every branch of science and engineering. Quantum simulators will use AI to design new molecules and understand exotic phases of matter. Astrophysical twins will model galaxies and black holes to decode cosmic evolution. Industrial twins will predict machinery wear, power grid stability, and spacecraft navigation. And as quantum computing matures, we'll soon see quantum AI hybrids, simulations that operate beyond classical limits, blending quantum mechanics and machine learning into a single, powerful framework. Eventually, we may have a digital universe, a full-scale simulation where every particle, field, and fluctuation is modeled in real time, enabling discoveries that bridge the gap between imagination and experiment. Why it matters. AI-driven physics simulations are more than a technological advancement, they're a philosophical shift in how we explore reality. Instead of waiting for the universe to reveal its secrets, we can now build it, test it, and evolve it ourselves. For students, this is the perfect moment to step into the future, a field where physics meets data science, and curiosity meets computation. For teachers and researchers, it's a chance to teach the science of prediction, not just observation. And for the curious mind, it's a new way to see that the universe itself can be learned, modeled, and understood through the language of AI. This is the Learning Studio, and this was our episode on AI-driven physics simulations and digital twins. If you enjoyed exploring how AI is reshaping the way we model reality, don't forget to like, subscribe, and explore the physics playlist linked below. In our next episode, we'll dive into quantum sensors and AI-augmented measurement systems, where precision meets intelligence at the quantum frontier. Because the next revolution in physics won't just happen in laboratories, it will happen in the digital mirrors of the universe itself.